All right. Let's see. I'm not gonna complain. I'm just gonna do this. I'm not like feeling that great, but I'm just gonna kick some butt. I'm just looking at all the problems. I think they all reduce to linear functions. I think. Let's work on them. But it's really important when you do these rational graphings that you do consider that. Like you always want to factor. It won't become a vertical asymptote if we can reduce it. It'll turn out to be a hole in your graph. So x squared plus 4x minus 12 over x minus 2. Factor at the top. So I get x plus 6, x minus 2. See, yeah. Provided we're not talking about x equals 2, then this is going to be equivalent to x plus 2, which is a graph that has a y-intercept of 6, 1, 2, 3, 4, 5, 6 or so, I don't know, and a slope of 1. So if I had to guess, our graph looks like this. But at x equal 2, we're not going to have a value there. So 1, 2, it will be up at 8. So at 2, 8, there should be an open hole. Open, I don't know if I can draw an open hole. And this open hole is at 2, 8. Otherwise, it's pretty easy to graph because it's just linear. I think the next one's the same. It's not a lot of variation, and they're really like honing in on this one skill. But I guess it's a hard skill. X minus 8. The x minus 8s again cancel out, and you get a linear function. Provided that x is not equal to 8, then this will simplify to that, which is just, y-intercept of 8, slope of 1, boom. At x equal 8, you're going to have an open hole. That's what it looks like. And it's really important that you include this open hole. And if you want, you can give the coordinates. It would be 8, 16. It's not bad. This is going to be like the quickest homework ever. 33. 33, f of x is equal to x plus 5 times, I'm going to factor the second quantity, x plus 3, x minus 1 over x plus 3 times x plus 5. And again, this all reduces down to a linear function. So the x plus 5s cancel out, x plus 3s cancel out. You get x minus 1. And this is true provided that x is not equal to -3 or -5. -3 and -5 doesn't exist, so we'll have to do something about that. So here's 1. We're starting at -1, slope of 1. We have this equation. I mean, in theory, you could do end behavior and all that stuff because there's no vertical asymptote, but there's still an end behavior. It's ending up in infinity. To the right and to the left, it's ending up to negative infinity. At -3, so we'll just say this is -3. You're going to have a hole here, and at -5, you're going to have a hole. It's no big deal. But make sure to indicate those holes. And if you want to put the y values, that's fine. It's not that hard to find. This is -5, -6. And this one's -3, -4. Looks about right. Not necessarily drawn a scale, but close enough. All right, 35. Please don't go to a linear. Let's actually have a vertical asymptote and make this homework more than 5 minutes. I get 2x to the 4th plus 10x cubed plus 12x squared all over x plus 5x plus 6. I guess it's a square. In the numerator, I can factor out a 2x. Actually, I can factor out a 2x squared. Oh, bro. I'll have x squared plus 5x plus 6. Okay, I don't want to cancel this out, though. I want to make sure I factor. This is going to be x plus 3, x plus 2. I think that looks correct. You want to make sure, 100% make sure that, oh, by the way, this doesn't go to a linear. It goes quadratic. You want to make sure that you understand where your domain issues are, because our domain issues are -3 and -2. So I'm going to factor this out. I know they're going to cancel out, but I'm just like putting this extra step. Otherwise, like if I just like canceled this out with the top, I might like forget where it's true. So now I'm going to cancel them out. This is just 2x squared. It's just a parabola. I'll graph a parabola. I know how to graph that. And b over infinity. Goes through 0, 0. It's going to bounce at 0, 0. And then at -2, -2, here's a hole. And at -3, here's also a hole. You can find the corresponding y value. That's not big. I believe this is -2, 8. And this is like -3, 18. That sounds right. There it is. Whatever's. Still not a good like question. I'm hoping for the next two are going to be like really good questions. They're probably not. We shall see. We shall see. All right, on to 39. I got f of x is equal to x plus 1 over, I'm going to go ahead and factor out the bottom, x plus 1 times x plus 5. I'm going to cancel out the x plus 1s. I got 1 over x plus 5, provided that x is not equal to -1. This is a true statement. As long as x is not equal to -1, that's why we have to have a hole. All right, so this is going to have vertical asymptote. It's going to have vertical asymptote at -5. It's not going to have any roots. It's never going to cross the x-axis. As x approaches infinity, you should be able to see that the function value approaches 0. The denominator is growing without bound, and the numerator is constant. As x approaches -infinity, f of x is also going to approach 0. So our horizontal asymptote looks like this. So, I mean, I can kind of see what the graph is looking like. It's like either going to look like this or like this. But we need to like plot points and make sure we're right. All right, so I'm going to pick a number less than -5, like -10. This is definitely going to be negative. So if I had to guess, I would say this bottom graph is what our graph looks like. Boink, boink. Now when x is greater than -5, I mean, you could plug in a point, find the y-intercept or something, but I'm just going to pick a number greater than 5, greater than -5. Maybe like, I'll just do 0. 0, it's 1/5. So just looking at like where my point is and understanding that I don't have any roots. So I can't go through. I can't go through. Like my graph has to look like this. It must. Let's talk about -1. We still want to be cautious about -1. When I plug -1 in there, I am going to get a hole, so I'm going to put a hole right there. And you can find the corresponding y value. This is just -1, comma, positive 1/4. It's a little bit greater than 1/5, but not necessarily drawn to scale. It's not bad though. That was easy. That was easy. All right, 41. I think yesterday's homework was a lot harder. Let's see, 6x squared plus 4x plus 2 over x plus 2. I can factor out 2 from the top. And I get 3x squared plus 2x plus 1 if I did that correctly. I don't know if that factors. I mean, it may factor, but it definitely doesn't have an x plus 2 in it. I don't think it factors. Nah, it doesn't factor. It'd be nice if it factored. Maybe I'm like being wishful, or maybe I didn't write it right down, but I think that's it. Nah, this isn't going to factor. And then when you do the discriminant, like the thing inside the square root, the whole b squared minus 4ac, this will turn into square root of 4 minus 4 times 3 times 1. So if you notice, this is the square root of negative 12. Oops, I messed up. Square root of negative 8. Yeah, we got negative 12 and 4 is negative 8. And then since the discriminant is negative, we have an imaginary value. But when we're graphing on the real coordinate plane. So we're not going to have a root. So let me get rid of this guy. It's very interesting what this is going to look like. So I get a vertical asymptote at x equals negative 2. So here's my vertical asymptote. Let's talk about end behavior. As x approaches infinity, the function is going to approach infinity. Just think about like infinity land. That's not going to matter. That's not going to matter. That's not going to matter. So that's going to become really big. As x approaches negative infinity, I believe this is going to be negative infinity. Like on top is always going to be positive, but then you're going to divide by negative. So the result's going to be negative. Yeah, so here's negative infinity. I don't have any roots, so remember that I don't have any roots. And I end up in positive infinity. So this is going to look like super trippy, but I believe our graph's going to look like, well, we're going to start off at negative infinity, which is our lowest point, and we're going to go up, and then we're going to follow our asymptote. Same thing here. We're going to be like, I mean, technically we can find the y-intercept, but I'm not going to. And then we're going to follow our asymptote like this. It's not like too exciting. I mean, it's common. It's common. I know like we want to follow like horizontal asymptotes. That seems easier, but there's no horizontal asymptote here. All right, so then let me drop this in Desmos just so I can check it. Oops, that was really awkward. So Desmos, oops. Plus 4x plus 2 over x plus 2. It's weird I don't have a graph. Add slider. Oh, I think I messed up. Equals. Wow. Looks nothing like it. You know, a little bit of a stretch, you know. There's negative 2. I mean, that kind of looks like parabolic on each side. If you look at this, it's like on the left-hand side of negative 2, it's parabolic with it being concave up. And then on the right-hand side of negative 2, it's parabolic with being concave. Oh, this is concave up. This is concave down. So, yeah. Más o menos. Anyways, there's the homework. Obviously, like, your teacher is going to have more problems for you to practice. There's, like, not enough practice yet. All right, thank you.